studied chemical thermodynamics. Got it? Chemical
Yes.
thermodynamics is basically about the, it is basically tells us what will be the heat of the reaction, how much heat is going to get liberated when a reaction is taking place, that you know. Okay. Chemical thermodynamics tells us whether a reaction is possible or not. Okay. But kinetics is about the speed of the chemical reactions. Got it?
Yes, sir.
So what is the definition of chemical kinetics? So this is the first question you can expect in your CBSE, okay, from this chapter. The first and the foremost question is, what do you understand by chemical kinetics? So basically it is the branch of the chemistry which deals with the study of what, Zainab?
Chemical reaction.
Yes, study of speeds of chemical reactions. Got it?
Yes.
Speed is also known as rate. Okay, so it is a branch of chemistry which deals with the study of speeds of chemical reactions and the factors which affect it. Can you give me some example of factors which can affect the speed of a chemical reaction? A reaction can become fast or it can become slow. Okay, yeah.
Catalyst.
Catalyst, exactly. Like catalyst. Very good. Yes. What else? What else? Catalyst is there. Temperature.
Volume.
Yeah. Temperature, volume actually changes the concentration. Okay.
Yes.
Temperature and concentration. Okay, and so on. So this is basically is chemical kinetics. Got it?
Yes, sir.
So I hope this is clear to you, right? Okay.
Yes, sir.
So first and the foremost definition is clear. So let's proceed ahead. Okay. So you study the speed of chemical reaction, and that speed of chemical reaction is known as rate of chemical reaction. There is another name of speed, that is actually the rate of chemical reactions. Okay. Clear? So the rate can be very fast or it can be very slow. There are some reactions, that take much longer time to complete. Rusting, that is very slow reaction. Okay. You don't see it happening because it is very slow. Formation of petroleum, formation of diamond in the earth crust took millions of years. Okay, that is very, very slow, right?
Yes, sir.
So, and there are some reactions which are very fast, like explosions, right? Precipitation reaction, where you mix two substances, AgNO3 and NaCl, you get white precipitate of AgCl. And there are certain reactions which are neither very fast nor very slow. So you have reactions with different speeds. Okay, you measure their speed in this chapter. The speed or the rate can be average rate or instantaneous rate. Okay, and how you measure, what you measure to measure the speed? Can you tell me?
Sir, could you repeat?
Yeah, to measure the rate of a chemical reaction, what you measure actually?
The concentration level.
Yeah, change in concentration of any reactant. of any of the reactant or product which is the part of the reaction per unit time. It is just like suppose we are traveling in a car, and if we are traveling in a car, how we are going to measure the speed? We are going to measure what is the rate of change of distance. Getting it?
Yes, sir.
So how the distance is changing with respect to time. So for chemical reaction, it is rate of change of
Concentration.
concentration with respect to time. Okay. So change is represented by delta, as you know. Concentration is represented by square bracket. Okay. I will write concentration, but actually suppose if you are measuring the concentration of nitrogen, you will write N2O2. Okay. And the change in time per unit time. Okay. Is it clear?
Yes, sir.
And this is basically what is the unit? Concentration unit is mole per liter. Got it?
Yes.
And the unit of time will be per second, Zainab, right? So do stop me if you have some confusion or if you want to add something new. Surely you can stop me anytime. Okay. So this
Yes.
is the unit of rate. So that is very good. You told me that the rate is measured by knowing the rate of change of concentration, and this is the unit of speed of a chemical reaction or unit of rate. Got it?
So should we write it down?
It should be,
Should we write it down?
yeah, you can write it down. Okay. Or you can now understand, you can also keep on writing little bit. Okay. And you will be having recorded lectures, so there also you can revise it. Okay.
Yes.
So units of rate of reaction. Okay. Clear?
Yes, sir.
The rate can be average or instantaneous. So what do you mean by average and instantaneous?
Instantaneous means the reaction takes place in a infinitesimally level of seconds.
Yes, exactly. So if you are talking about the average rate, basically, you are measuring in a time interval, okay? In certain time interval. That is actually the average rate. Got it? Average rate is basically is measured between two time interval like 5 to 10 minutes, okay? That is the average rate of reaction. Instantaneous rate is at that particular moment. Suppose if I'm traveling in a car in 1 hour, what is the average speed? And what is the speed right now? Okay, that is the instantaneous speed. Okay, so average rate and instantaneous rate. Average rate is written by delta. Okay, change in concentration upon change in time, and instantaneous speed is because you take the time interval very short. Okay, so it become d by dt. D change in concentration, d by dt of concentration. Is this clear? This is just for definition. Okay, clear? So average rate and instantaneous rate. So average rate is measured over a long time interval. That's why it is called average. It can be slow, it can be fast. Suppose car, sometimes it stops, sometimes it is moving very fast. Okay, so you measure the average total distance upon total time. And instantaneous is that at that particular moment, means at now what is, okay, what the speed of the car, that is instantaneous speed. This you know, right? So suppose if you have a reaction in which the reactant R is giving you products. Got it? So how the concentration of R is changing? You can look here. The concentration of R is represented, and it is because it is a reactant. So what will happen to the reactant, Zainab?
From the product.
What will happen to the concentration of reactant as the reaction proceeds?
It will change.
It will
Decrease.
change. It will get consumed, so it will decrease. Okay.
Yes.
You can see the concentration of the reactant is slowly it is becoming less and less and less and less as this is the time. Got it?
Yes.
So suppose if you want to measure the average rate, you take two time interval, time t1 and time t2. That could be 5 to 10 minutes. You will be provided in basically you will be provided a table, numerical values. So suppose if I ask you to measure the average rate between time t1 and t2, how you will measure? You will measure the yeah. Tell
Begin
me.
concentration by the time.
Yeah, change in concentration. Change in concentration is final concentration. Okay, final is time t2. This is c2 minus initial concentration of r. Initial is 1 upon t2. 10 minutes. They will give you the value 10 minutes or 5 minutes minus t2. Okay, and this is going to be negative because it is reactant. So rate always is positive, so this is just symbolic. So always either you should write the positive value, or if you are using the final minus initial because it will coming out to be negative, put a negative sign to make it positive. For reactant you need negative sign. That's it. Okay, clear?
Yes.
That much you can remember that because reactants are decreasing. Got it?
Yes.
Okay, great. So, and what about the product? So the average rate, you measure the change in concentration, final concentration minus initial concentration divided by the time interval and that change is happening, right? Now what you will do, you will basically can also calculate the change in concentration of product. If you look at the concentration of product, this is the concentration of product. It is going to increase. Got it? As the time progresses, it is increasing. You can see over here, right? It is moving up. And suppose if somebody asks me to measure the speed or the concentration or rate of formation of product, rate, I'm using the word formation. Got it?
Yes.
Because product is increasing, so it is forming. Reactant is like this, it is coming down. Product is increasing. So you average rate is change in concentration of the product upon the time taken for that change, but you are not going to put the negative sign because product is always increasing. Or you are going to write it like this: concentration of the product final minus initial. F is the for final, I is for initial upon T final minus T initial. Got it? Clear? So this is how you're going to calculate the average rate between time T1 and T2. They will give you the values. T1 and T2 could be 10 minutes, 15 minutes, or 15 or 20. Right? But
So can we calculate using differentiation?
yes, exactly. You can calculate. Very good. You can calculate using differentiation if it is asked, if it is given that you need to find the instantaneous rate. Instantaneous rate means at particular time t. Suppose if you have just time t. So there you do not have two different points like t1 or t2. You have just one time interval. So there you can measure the slope of the tangent. Slope of the tangent, that is Slope of the tangent is calculated by differentiation, as you told very correctly. Change in concentration of product dp by dt. Okay, and it is going to give you instantaneous rate of formation. Of the product P. Got it? So I hope this is clear.
Yes.
Okay. So this is how it is done. So you have average rate and instantaneous rate. Let me give you a question. And suppose you have a reaction where the nitrogen gas and hydrogen gas, they are reacting together to form NH3. Okay, at minute, time is measured in minute or seconds, so do keep track of that. It will be given in the question. So 0, 5 minute, 10 minutes. Okay, and the concentration of ammonia, NH3, it will be given in the question. Okay, it is going to be 0.05. The units are mole per liter. 0.06 is 0.065. Got it? This is 60. Right? So what is the rate of formation of NH3? Average rate of formation. This is average or instantaneous, because it is given between the two time intervals. So this is average. Average rate of formation of NH3. Okay, between 0 to 5. Between 0 to 5 minutes. Yes, what it will be, how to calculate?
The change in concentration of N2.
Yeah, delta NH3. For NH3 they are given. Okay. So change in concentration of NH3 upon the time taken for that change. Okay. I'm not going to put the negative sign because this is a product. Okay. So between 0 to 5 minutes. So 0. So this was the initial concentration. This is the final concentration. Understood?
Yes.
So final concentration 0.060 minus initial concentration 0.050 divided by the time. And how much is the time? 5 minus 0 mole per liter per second. Got it? So it is going to be 0. If I take the difference, it is 0.010 divided by 5 mole. So what could be the answer? Per minute, not second. Okay, because the question is actually given in minutes. Got it? The time is in minutes. That's why. So it is 0.005, 002. Got it?
Yes.
Mole per liter per minute. I hope this is clear. Any doubts in this? Similarly, they can, if they ask you, do read the question very carefully in CBSE. If they ask you about the rate between 5 to 10 minutes, so you are going to use these concentrations. Got it?
So we are not using the 10 and 0.065 with 0.002 and differentiating it.
Differentiation, actually, if they have given you the graph or the slope of the tangent, then you can use. Otherwise, or if they have given the function. Pardon?
Are we not subtracting that value, the third value and the current value we got?
I didn't get your question. Could you please repeat?
So there are three values, right? They gave three time and the three change in concentration. We have
Yes.
used only two, right? So are we not using the third one?
We should use that, depend upon the question. This question is talking about
0 to 5 minutes.
So I have used these two values. Got it? If the
Yes,
question
sir.
is talking about 0 to 10 minutes, I should use the first and the third value.
Yes, sir.
If the question is talking about 5 to 10 minutes, I should use the second value and the third value. Got it?
Yes, sir.
So this, I hope, is clear to you. Okay. Very good question you asked, that which value should we use. So you need to look at the question very carefully on what time interval it is talking, about which time interval it is talking. Got it?
Yes.
Okay, great. So I hope this is clear now. Your doubt is clear.
Yes.
Okay, great. So you can measure. This is the balanced chemical equation, and you can measure the rates of A, B, C, and D by differentiation or by calculating the change in concentration. dA by dt, dV by, because they are reactant. Because they are reactant. So I will put a negative sign so that I should get a positive value. And these are the products. So there is no negative sign because already we are going to get a positive value for these. Got it?
Yes, sir.
So this, I hope, is clear to you, right? So
Yes.
okay, let me take one example about the same reaction which we have written. N2 plus 3 hydrogen giving you 2 NH3. So in this case, rate of consumption of nitrogen, delta N2 by delta T. Got it?
Yes, sir.
I should put a negative sign. Rate of consumption of hydrogen. What should I write? Can you tell me, Zainab?
Delta in H2, the whole raised to 3.
By delta T. I will, because this is will decrease. So to make it positive, I will put a negative sign. Okay, so negative will become positive. Okay.
So are we
Or,
now putting the 3 as the power?
pardon?
Are we now putting the 3 which we balanced as the power of H2?
Yes, I'm coming to that. As of now, that is, if somebody asks me rate of consumption, rate of consumption or rate of disappearance of hydrogen, we are going to use just change in concentration of hydrogen divided by the time taken for that change. When to put 3, I am coming to that. Similarly, if you have for ammonia, I should say rate of formation. Got it? Of ammonia. Are you getting my point?
Yes.
So this is going to be delta NH3 by delta T. If they are talking about ammonia, just to change in concentration of ammonia by time. Okay, as of now, I've not put any 3 or 2. When to put it, I will talk about it. There is no negative sign, you can see here. Got it? Why? Because it is a
Formation.
It is a formation, it is a product.
And it is a product.
Yes, exactly. So now my question is, are they all same?
No.
No. As you noticed very correctly, that this is 1 mole, okay, and that one is 3 moles, and this one is 2 moles. Got it? So
Yes.
if in a minute, let's say in a minute, X moles of nitrogen are being consumed, as per the balanced equation, 3x moles of hydrogen will be consumed. Getting my point?
Yes.
Because the coefficient is 3. And in the same time interval, how many moles of ammonia will form or NH3 will form?
2 moles of ammonia.
Yeah, 2x. Got it. Clear?
No.
So surely they are not same. If the coefficient is more, it is being consumed at a being consumed more rapidly. If the coefficient is smaller in the balanced chemical equation, it is going to get consumed slowly. Getting my point?
No.
So they are not same. And now my next question is, which one should I consider for considering the rate of the reaction?
Could you repeat?
Which one should I take? Should I take this one, or this one? Because they are not same, that we have seen already. One is X, another is 3x, or for ammonia it is twice. Okay. For overall rate of reaction, but the reaction is same. So which rate should I consider? The rate of N2? Should I consider the rate of hydrogen, or should I consider the rate of formation of ammonia to represent the rate of the complete reaction? Which one should I? Pardon?
Formation of ammonia.
Formation of ammonia, you may be saying it because it is a product.
Yes.
Yeah, this could be a good idea, but the another thing, if you think, it will be that because all 3 are the part of the same reaction. Okay, so it should be such that the rate I should measure with either nitrogen or hydrogen or ammonia. It should come out to be same because all 3 are connected by a same chemical reaction. They are part of a same reaction. Getting my point?
Yes.
So I should get a same value. So what I do, in order to connect all the 3, okay, I will write it like this. Rate of this reaction is equal to delta N2 by delta T minus, because it is being consumed, equal to, and we know that this is not equal because it was being consumed at thrice the rate of nitrogen because its coefficient was 3. So I know that these are not equal. Are they equal?
No.
No, they are not equal. Because if this is x, this is 3x, and x and 3x are not equal. I can make them equal. I will divide it by 3. I will divide it by stoichiometric coefficient of its respective coefficient in the balanced chemical equation. Then they will become equal. Got it?
Yes.
Similarly, are they equal to the rate of appearance or rate of formation of NH3?
No.
No, because NH3 was forming at a 2x rate. Okay, they were not equal. NH3 was forming at a twice the rate So it was forming it at twice the rate. To bring it at par with the other two rates, I divided by 2. And so my conclusion is there are rate of consumptions and formations for each reactant and product. Okay,
Yes.
they may or may not be equal, but in order to make them equal, you divide each rate with its stoichiometric coefficient of that particular reactant in the balanced chemical equation. Getting my point? And then they will become equal, and they will represent each one now will become the rate of the reaction. Okay,
Multiply it.
because if you multiply, it is already multiplied. Suppose if 1 mole is being consumed in 1 minute, in 1 minute 3 mole is already consumed. Getting my point?
Yes.
If you multiply by 3, it will become 9, so they are not becoming equal. So
Yes.
N2 is moving at some 1 mole. 1 mole was reacted, same time 3 moles were reacted for hydrogen. They are not equal, that we know. To make them equal, what I do? I divide this by 3. Got it?
Yes.
When I divide it by 3, they both become equal. And they start representing the rate of the reaction. So if I ask you what is the rate of disappearance of, I'm writing it in abbreviated form, rate of disappearance of hydrogen. Rate of disappearance of hydrogen is minus delta, disappearance means negative H2 by delta T. And what is the rate of reaction? Complete overall reaction?
Concentration of NH3 by delta T.
Yeah, or you can we find it by H2 also?
Yes.
Yes, but what to do in order to make the rate of H2 to become equal to the rate of the reaction?
We should divide it by its coefficient.
Yeah, we should divide it by the respective stoichiometric coefficient in its coefficient in the balanced chemical equation. So I made it 1/3. So you measure each individual rates. When you divide them by coefficients, they become rate of reaction. Are you getting my point?
Yes.
So this is the relationship, because you need to divide it by the stoichiometric coefficient to make them equal. Otherwise, they were not equal. Okay. So look here, this is the equation. Okay. And you have capital A, B, C, and D representing the reactants and products. And small a, b, c, and d are representing their coefficients in the balanced chemical equation. So this is rate of disappearance of A, rate of disappearance of B, rate of disappearance of C, rate of disappearance of D, individual rate, and they become equal when you divide them by their respective stoichiometric coefficient, B. Each by its respective stoichiometric coefficient in the balanced chemical equation. And then now they become equal. They become equal to what? They become equal to rate of reaction. Getting it?
Yes.
So units already we discussed. It can be mole per liter per minute or per second. You need to look at the question, the data which is given in the question. Okay. And
Yes.
with that you can find the unit. Okay. So this is there is a reaction in which the reactants and products are represented by A, B, C, and D. But you don't know whether the reactants were A and B or A and D or A and C or B and C, or who are the products, who are the reactants, you don't know. But this is the relationship. A, B, C, D are all part of the same reaction. And this is the relationship between all four of them.
Yes, sir.
Clear? This is the relationship between all four of them. So, can you tell me what will be the balanced chemical equation? This is a reverse question.
Can I take a minute?
What is the balanced chemical equation? The equation is not given, the rates are given, their relationship are given, and you are asked which is the balanced chemical equation for this reaction where the rates are represented by this relationship.
Option
Getting
C.
which one?
Option C.
Option C. Yes, very good. How you decided?
Because when the product is consumed, they are denoted with a sign minus,
Exactly.
and found it is plus.
Exactly. So you had minus means B and D were reactants. So B and D were reactant and C and A were products. You can see over here. Okay. And you have positive sign. So these are being formed. That's why there is a positive sign. Their concentration is increasing. Okay. And the coefficients you have, you will find in their denominator. Okay. So the coefficient of B is 1 because you do not have anything. So this is just 1. The coefficient of D was 3 as is you have it in the denominator. Okay. Coefficient of A is 4 and C is 2. Very good. Okay. So this C is the right option. Right. So let's do the numerical. This is the same thing which we discussed. So just quickly tell me the answer again. Just a quick recap of what we discussed just now.
Option C.
Option A N2, yes, minus sign, H2 minus sign and divide by 3. Ammonia NH3 should have positive sign because it is being generated. Yeah, and divided by 2. Yes,
My
option.
answer is option A.
Yes, option A, correct option. Very good. So this you understood very well. Okay, great. So let's get into the numericals now. Rate of disappearance of the permanganate ion in the following reaction is this much. This is how the permanganate ion is reacting. So is it 1 by 2 of permanganate rate of permanganate ion, or is it just the rate of change of permanganate ion from the data what you can analyze?
1 by 2 of permanganate ion.
1 by 2, that will be the rate of the reaction. When you divide it by stoichiometric coefficient, it becomes the rate of the reaction. And
So it just becomes a concentration. It changes.
yes, it is the rate of disappearance of the permanganate ion MnO4 minus. Okay. So it is basically delta MnO4 minus by delta T. If you talk about particular reactant or a product, rate of reactant or product, don't divide. If you are talking about the rate of overall reaction divided by stoichiometric coefficient. Got it?
Yes.
So the one which is given in the question is this one, 4.56 into 10 to the power minus 3, right?
Yes, sir.
Mole per liter is represented by capital M per second. Okay. So what is the rate of the reaction? and rate of formation of I2 in that same time interval. You can tell me two things. Rate of reaction and rate of formation of I2. So first you need to connect. Okay, they are not same. You have coefficient 2, you have coefficient 5. So one is moving 5 times faster, another is moving 2 times faster. That definitely, surely they are not same. Got it?
Yes.
So how can I make them same?
You have to divide it.
Yeah, divided. So 1 by 2. This you understood?
Yes.
Okay. So now I'm going to put this value here. And this is the rate of the reaction itself. Okay. So 1 by 2 into 4.56 into 10 to the power minus 3 mole per liter per second. Got it? Equal to 1 by 5 change in concentration of I2 by J. Time taken. If the so I equated them by dividing by respective stoichiometric coefficient, then they become equal, and delta I2 by delta T can be found out by cross multiplying this. Okay, got it?
Yes.
So what will be the answer? Can you tell me quickly? What is going to be the answer? .28 into 5 and
One.
how much you are getting? Yes, 8 into 5 is 40. 4, 5 into 2 is 10 and 4, 14. Yes.
16.40.
11.4. You need to multiply it by 5. 5 into 2 is 10 and 1 11. Okay, into 10 to the power minus 3. So it is going to be 1.14 into 10 to the power minus 2. Okay, I will shift this decimal here and 1.14 into 10 to the power minus 2. Got it?
If we shift the decimal, the -3 should become -4.
Yeah, it could be, yeah, because it is this divided by 11.4, or you can write it like this: 11.40 divided by 10 to the power 3 when you bring it in denominator. Okay, so
Yes.
just divide by 10 and make it 1.14, and you are left with 2 zeros now, because one you have already divided. Okay, by
Yes.
dividing, the decimal will move toward the left hand side, so it is 1.1 into 10 to the power minus 2. So I hope this is clear to you. Okay,
Yes.
got it? So D is going to be the right answer. Okay,
Yes, sir.
so now I hope you understood. So this, sometimes it is not always that we have to get into the detail. There are some small tricks also. For example, this question without getting into the detailed calculation, you can do it by trick also, but in CBSE you need to write all the things which I told you to get the marks. Okay, What they have given, this is the reaction. And rate of formation of NO they have given is this much. So what is the rate of consumption of ammonia? This they are asking. Now without calculation, I can quickly tell that it is going to be same as the rate of formation of NO. Can you tell me why?
They explain it again, I will understand.
Okay. Without calculation, I can predict this one and this one both are same. How I predicted this? Can you tell me quickly without I have not written anything?
It is the rate of formation and disappearance.
Hmm?
Rate of formation and disappearance both are seen by the coefficient.
Yeah, why they are same? Because
Coefficient.
their coefficients are same. Got it? So what is the rate of disappearance of ammonia? That is same as the rate of formation of NO. And that is 3.6 into 10 to the power minus 3. Got it?
Yes.
So first one is going to be the answer. But this is, you need to write the detail. Okay. I just told you to check how to check your answer quickly. But in board examination, you need to write each and everything in detail. Getting my point or not?
Yes.
So just suppose if the coefficients are same, the rate is going to be same for both of them. Okay. And if I
Yes.
want to get the rate of the reaction, I need to divide that rate by its coefficient. Okay. So what is the rate of the reaction? Can you tell me quickly? Rate of reaction, if you have rate of NO as 3.6 into 10 to the power, this is for NO minus 3. So what is the rate of the reaction?
1/4 into 3.6.
Yeah, rate, yeah, 1/4 into 3.6 into 10 to the power minus 3. Very good. Yeah, you will divide